Hello, everyone. Today, I will be presenting our work titled Enhancing Hands in 3D Whole Body Pose Estimation with Conditional Hands Modulator, which is being presented at CVPR 2026. Our goal is to achieve accurate 3D whole body pose estimation from a single input image. Compared to existing methods like OSX and CVPR, our Hand4Whole++ produces much more accurate hand poses within the full body context. Existing approaches face distinct limitations. Hand pose estimators recover isolated hands well but lack the necessary full body context for complex interactions. Conversely, whole body pose estimators capture the global human structure but suffer from low hand accuracy due to limited hand diversity in their training datasets. A naive combination of these independent models, which simply copies and pastes the hand model's results to the whole body, typically results in anatomically implausible wrist and hand configurations when hand model's results are bad due to occlusions. To address these issues, the Hand4Whole++ framework is introduced. It is primarily trained on hand-only datasets to capture diverse poses, despite the absence of full-body labels. The framework employs foundational whole-body and hand pose estimators, keeping them entirely frozen during training. Only a lightweight module named CHAM is trained, providing an efficient plug-and-play solution. The overall architecture leverages these frozen pre-trained estimators to preserve their specialized expertise. The Conditional Hands Modulator, or CHAM, refines whole-body features by injecting informative, hand-specific cues. Hand-specific accuracy is incorporated for wrists and upper body poses through CHAM, while fine-grained finger details are transferred via rigid alignment. CHAM provides hand-specific conditioning by injecting features into the whole-body stream. It uses inverse affine transformations and zero-initialized convolutions to maintain precise spatial alignment with the global body context. Furthermore, this lightweight module is optimized for speed, adding only 10 milliseconds of latency to the total inference time. The architecture utilizes a hand-to-body injection strategy. Modulating whole-body features with hand features allows the framework to improve all upper body joints. Conversely, a baseline body-to-hand injection approach would fail to improve these upper body joints and would suffer from incorrect relative positioning of the left and right hands. Directly fine-tuning a pre-trained whole-body pose estimator on hand-only datasets leads to severely distorted body structures, as these datasets lack whole-body labels. By exclusively training the CHAM module, the framework successfully preserves the robust capabilities of both pre-trained estimators while effectively correcting inaccurate upper body joints and hands. For fine-grained details, the framework leverages stable local finger poses from the specialized hand estimator, discarding its unstable global wrist predictions. Final wrist placement is determined solely by the CHAM-refined body model. The detailed hand mesh is then seamlessly aligned using a differentiable rigid transformation based on the wrist and MCP joints. Quantitative comparisons highlight the effectiveness of this approach. Original whole-body estimators suffer from inaccurate hand details, while hand-only estimators produce implausible poses within a whole-body context. Hand4Whole++ effectively preserves baseline expertise and significantly improves overall accuracy compared to naive fine-tuning strategies. Qualitative evaluations on challenging in-the-wild images demonstrate that Hand4Whole++ consistently recovers accurate and natural hand poses. During complex interactions, such as holding objects or eating, the framework effectively integrates hand precision into the global body structure, outperforming recent state-of-the-art models like CVPR and multi-HMR. Additional results highlight the robustness of the framework under severe truncation and self-occlusion. In scenarios where baseline models predict disjointed wrists or collapse the hand structure entirely, Hand4Whole++ maintains a stable, physically plausible upper body kinematic chain driven by the spatially aligned modulation. The stability of the framework extends to dynamic motions in video sequences. Visualizations confirm that Hand4Whole++ effectively tracks complex hand gestures and varying ranges of motion over time, overcoming the low-end precision observed in existing whole-body estimators. Extensive quantitative evaluations firmly establish Hand4Whole++ as a new state-of-the-art. The framework outperforms all existing whole-body pose estimators on major full-body benchmarks. Furthermore, despite being a whole-body framework, It surpasses specialized hand-only pose estimators on challenging hand-centric datasets. Strong performance on highly truncated images opens new avenues for research. Observations indicate that Hand4Whole++ is exceptionally effective for hand-centric scenarios, such as egocentric viewpoints. Extending this modular framework for dedicated egocentric perception represents a highly promising direction for future development. In summary, Hand4Whole++ is a high-precision, modular 3D whole-body pose estimation framework. It efficiently processes a single RGB image to output standard SMPLX parameters. Its innovative plug-and-play modularity achieves state-of-the-art results without the prohibitive computational cost of full-body retraining. Our code is publicly available in our website, so please check it out.